All right, everybody, let's kick off the 22nd installment of the Local First Meetups. I'm so excited for the lineup. I know I'm basically a broken record, but literally every one of these lineups end up being like an amazing group of people to bring up. And we have the veteran Aaron Michael has been in this space for way longer than almost all of us. He'll tell you a little bit about this story. I first got introduced with remote JS to kind of this space way back when. Lakan's got a wonderful product that he's going to talk to us about, and basically, let's get that party rolling. Uh, like I mentioned, first up we have Hakan, and he's been working on Colonnade, Colonnade, Cola Node, and I got a chance to see it through the show Lo-Fi broadcast channel. If you have a cool project you want to highlight, please drop it on there. It's an opportunity for you to get some visibility with like-minded people, and that's usually what I look through to find some interesting meetups to share as well. Hakan is the founder of Colonode. Hopefully, you'll correct me on how to actually say that.
Yeah, that's correct.
Okay, Colonode. And it's basically what I've been looking for, and I can't wait to learn more about what he's got going on in there. He's had lots of experience building large-scale businesses and software. And well, let me hand it over to you, Hakan.
Thanks a lot. And hi, everyone. It's very nice to be here, and thank you for the opportunity to present Colanode. Just to mention, like the name comes from like two words, it's collaboration and node, and it was just a
Oh,
free domain, and that's where Colanode came from.
nice.
So let me share the screen. I've made a few slides, and I will just speak mostly about how it works and what we've been working on. Okay, so as mentioned, Colanode is an open source and local first collaboration workspace. The idea is that you have all-in-one application for collaborating with teams, projects, groups, or like individuals or whatever use case you might have. Briefly mentioning some of the features that you can see in Colanode. Yeah, sorry, I thought someone going to say something. Okay, some of the main features that you can use in Colonel is like you have a real-time chat when you can discuss with in groups or direct messages. You have rich text pages, similar as you have in Notion, like blog-based editor. When you can have like nested pages, you can have different kinds of blogs, headings, or different kinds of formats. You also have what we call like customizable databases. Think of them as some kind of advanced spreadsheets with custom columns, views, ordering, filtering, etc. And also it contains the file management in there. So I'm not gonna stop too much in how the what Colonel does because it's similar of some of the other tools that you have used. And since we are here in the community of local first, I'm gonna mostly focus on the part of the technical part of the local first, the sync engine, the architecture, and similar stuff. So how it works, like Colonel has two main components as of now. We have the desktop app, which is built in an Electron.js, and it uses SQLite and the file system for storing the content locally. And it has a central server, which acts like as a proxy to connect with different collaborators, different desktop apps, and synchronizing stuff. And in the server side, we have like a Node.js app built with Express.js, and we have like Postgres as the central storage for the data. We have S3, any S3 compatible storage for files, and we use Redis for some caching, rate limiting, and some background jobs where we use BoolMQ from Node.js ecosystem to perform some background jobs, etc. So in the desktop part, like the main part of Colanode, the thing is that the desktop application of Colanode can be connected with any server. By default, you will have two options. Like we have two hosted cloud options of Colanode, one in EU region and another one in US, depending on where do you want to store the data. But you can easily the same desktop app you can connect with other servers anywhere that you host them, and then you can do that through the interface. You don't need to custom build the app or change the code or anything. You can just download the official desktop app from Colanode website and connect it with any server that you want. Once you're connected with a specific server, like you typically use an account, you can have multiple accounts for the same server or different servers. And then with one account, you can have multiple workspaces when you work. Workspaces, think of them as a project, organization, or a specific, let's say, product or any use case that you might have. Now, for each project, we store separately an SQL database where the content of that workspace is stored locally in your device. And also we have like the files directory for the files that are shared, uploaded, or downloaded by you. Now we can take a use case. How is like the flow of synchronization between the desktop app and the server? Let's say you're a user and we can take as an example the message flow because it is the easiest one. Let's say you write a message. The first thing that happens is that that message is stored in the local SQLite database in the messages table, and also we store a mutations queue where we have all the pending changes or pending mutations that need to be synced with the server. Then there is a background service that gets these mutations periodically or as they are happening, and then in bulk, it sends them to the Colonode server through the API. A Colonode server in the API, it performs like different kinds of validations. For example, authentication, authorization, if the data is correct, like right fields, missing data or anything. And if everything is correct, then it stores that specific entity, in this case, message, it stores in Postgres, and it notifies the real-time service that a new message has been written by a specific user. And then the real-time service sends this message to all other collaborators who have access to that message, so they will also get it in the desktop app. And then once that message is pushed to the Colonel desktop, it's also stored in other users' devices, like in the SQLite, and then all the reads and writes are happening locally. We'll get into that, how that happens in details in the future. Now, how does the sync engine know that something new has happened? So what we did, we implemented a similar approach as Kafka does, like with offset-based synchronization. Think of it as that the desktop is a consumer and the server is a producer. And to achieve that, what we do is that in all entities that need to be synced locally, for example, messages, entries, files, etc., we have a special column which we call version, and then for that version column, we use a Postgres sequence which auto increments on each insert and update, which means like we have a auto increment sequence of numbers and then we have the correct ordering of sync. So this is how it happens in the server side. Now, how does the desktop app sync with that? What we do is in the desktop app, we store like in the same SQLite database, we store cursors for each type of entities that we need to sync. For example, if we want to sync messages, then we have a specific cursor for that message, which is like the offset where we left off when the last time we have been synced with the server. And then the desktop app continuously through WebSockets asks from the server, give me new messages after the, let's say, version 10,002 or whatever number is there. Then the server checks if there are new messages in there. If yes, it returns to the desktop syncs locally, and then it asks again. So it updates the cursor and it also performs continuous incremental synchronization. This helps also if let's say the desktop app has been offline for some time, and then once you're back online, you have the last synced version. You just ask for new things, and then it synchronizes. And also for the first time, when you let's say install for the first time the desktop app in a new device, then you will have like all cursors like in zero position, and then you will do like from the beginning all full synchronization, and then incrementally all the changes that are happening in the meantime. One thing to notice here is that we also use the chat ID and messages as a cursor. And the reason why we do that is because uh, all the messages in the server, let's say, or all the entities in the Postgres, they have auto increment sequences, but sometimes it might happen that in a specific entity, you might gain grant access later on, and your offset might be like a higher number than the messages that you need to sync for like a previously created a channel. So to do that, we like separate the cursor like for specific let's say entities that you have access to. So even if you gain access later on, or your access has been revoked later on, like these cursors are separate, and they have like their own offset and their own synchronization. Similar as you might do, for example, for topics in Kafka or other similar, let's say, think think engines. Another thing to which is important in here is that the synchronization part in the desktop should be idempotent, meaning even if you get the same message again, which might happen in some rare cases that you might get the same message again, then you can, if everything is synced, then you can just ignore it and then move on to the other parts. And the most important thing is to not miss any data. And if you get the same data twice, that's okay. So this is like for the, let's say, more simple types of entities. For example, messages. In messages, you don't have concurrent edits, so the synchronization is like simpler. Like you get the whole message changes and everything. But there are also other type of entities when you have concurrent access. For example, pages, databases, records, or other similar stuff. And these kind of entities, we call them entries in Colanode. And these kind of entries are something that multiple users can work at the same time at the same entity. So what we do here, we use YGS, which is a CRDT implementation for some shared types that you can use for example, multiplayer documents. And also we have built an abstraction on top of YGS using ZOD schemas, which helps us to have like different types of entries, different types of fields automatically merged by YGS, which makes it easier to extend Colonode in the future, for example, to do some kind of, let's say, canvas or other types of, let's say, concurrent documents that you might need to work on. So how does this YGS abstraction actually work? Is all you have to do is, for example, if we are going to define the page that we are going to work in Colanode, then all we do is we define the attributes for that page. For example, we have like the object of the page, which has a type, which is like a constant of page. We have some names, avatars, parent ID, or whatever else it might need. And we also have the content. Then content is a nested object, which has like other fields. Now, in the right side, I've displayed what are like the abstractions or the types, data types in YGS that represent these kind of ZOD schemas. For example, for an object, we have the YMap. Then if you have nested objects or nested arrays, then they are created as nested maps. This is very helpful from YGS to have this kind of complex objects or complex YGS documents. And then another thing that we did is we created a custom data type in YGS for the ZOD text, because if you just write z.string, which is a string representation, then we just override whatever value is there. But if you want to let's say resolve if multiple users work, for example, in the same paragraph, we have created a special type which is ZOD text, which is resolved by the Y text data type in YGS. And then you also have the Y array. So for example, if you create a page, then all you have to do is generate an ID. We use different types of IDs, suffixes for different entities. You just define the page attributes, which are automatically inferred from ZOD schema, and that helps in type safe writing and developer experience. And then all you have to do is create a new doc for that abstraction and just send them the page attributes, schema, and the attributes that you want to store, and then the YDoc abstraction just checks everything that has been changed. It stores in the YGS document, and then it returns an update, which is a transaction for that specific, let's say, operation. This works in creates, updates, or whatever changes that you might do. As an example, how it works, for example, with text, if you have a text change, for example, we just compare if they are the same text, we just skip it. If not, then we use the npm diff package, which returns the minimum number of changes that we need to do in the text, and we perform that in YGS, and this tracks internally as part of one transaction inside the YGS, and then that returns to us one entry transaction, as we call that. So how do we store that for the persistence? What we do is that we store all the transactions in a special table, which is called entry transactions. Each transaction has a unique ID, and it has an operation which can be a create, update, or delete. And it also has like this Postgres sequence. When you create it for the first time, the version is 0 and is like added to the mutation queue. And once it's synced with the server, it gets like the right version. This also helps us if some of the mutations are, for example, invalid, then we can just delete that transaction, and then everything else works as expected. So now let's say we have like a list of all the operations that have been done in a specific entry. For example, we have created the page and then we have performed multiple updates. And then what we also do is that we save a snapshot of all those operations as one entry, where like the attribute is the JSON field of that entry. And when we use this entries table for read queries inside the app, for example, list me all the messages, list me all the pages, list me all the records, or get this specific database or anything else. So all the changes, mutation are done inside the entry transactions table. This is the single source of truth. And then the entries is just a derived snapshot of all the changes, like the final document, which is used for like listing and also everything to be displayed in the UI part. This also makes it easier for reverting of mutations because you can just delete any transaction in the entry transactions table, then just recreate the snapshot, save it, and then the rest is working as same as other parts. And the same applies also if someone from like a remote device or another device has made a change, then you just get like the minimum amount of changes, which is just that specific transaction that comes and stored locally, and then you just recreate the snapshot in the background. There are some special cases that need to be handled in here. For example, deletes are kind of hard to do because if everything is stored locally, you cannot just delete the record in the server. You need to somehow inform all the tombstone records for different types of entities. For example, for entries and transactions, we have a special delete transaction which has no data, but just like a delete, which tells the desktop app to just delete everything. And for messages and files, we just create a separate table when we just store the deleted IDs to just make sure that everything is deleted locally. These tombstone records are stored only on the server side. We don't store them in a local device. Also, one of the things that I mentioned before is as access grants and revocations. That is kind of problematic. You just do one synchronization, but we do that based on like specific entries that you got access to. And then if you get access later on for a specific entry or specific, let's say, entity, like a new cursors are created, and you can just retry and resync everything as needed. And also, if something fails in terms of like authentication or validation or whatever, for whatever reason from the server, the desktop retries up to 10 times to sync something. If that fails, then if that's a transaction, like for the entry transaction, it just deletes that locally. Or if it's a message or a file, that deletes it locally entirely as well. And then it updates the UI as expected. Now, how do we update the UI? Because for some of you that have worked like in Electron app, you have like two processes. You have the renderer process, which we use React, and then we have the main process, which is like a Node.js and has access to the native file system and everything. And this is the part when you work with where you work with SQLite or other, like let's say, content stored locally. And there is like an inter-process communication happening between them. So how do we achieve reactivity? We use React 10 stack, which is quite helpful and has some ready things. And we consider the main process as some kind of, let's say, server or an API. And for example, if you want to retrieve like a list of, let's say, give me 20 messages for a specific conversation, you just build this React hook and similar as React 10 stack does. And then what that happens is that what we do is that we get that input, which is type safe. We have like a map of all types of queries. We just hash it, and that generates a specific query ID. And then that sends a request to query and also subscribe for different changes in the main process. So well, even if you make the same request like from two different components, it still makes just one request in the main process, and that is handled by the React 10 stack part. And the flow is like you make the query, there is a query handler in the main process, which performs a query in the SQLite database. It returns response, and then it stores it on an in-memory query subscriptions. When you have all the queries that you made with their ID, and then if a mutation happens, then mutation handler based on some event system just tells like the in-memory query subscriptions, hey, something has changed. Just check all the queries, previously queries, if something has changed, and you need to inform the UI. If that happens, then the in-memory subscriptions through the IPC sends a request to the root 10 stack and says, okay, to the query with this specific ID, the result has been changed, just update the value, and then the React 10 stack just takes care to update and re-render all the React components. Also, the good thing about React 10 stack is that after some time, it first like it caches like the same query keys there. So even if you change frequently like different tabs, you don't have to go all the time to the SQLite. If nothing has changed, you just have them cached in that specific render process. But if after some time you haven't used that query, then React 10 stack automatically removes that from the cache. So we subscribe to that, and then we also tell the in-memory query subscriptions to the main process, hey, this query is not anymore in the cache of 10 stack, so remove it. You don't have to check for changes, and that helps for keeping like a small memory footprint or like that small, let's say, usage from the app itself. So this is all that I have. I know that there are a lot of details like in different parts, but I was just focusing like on the main flow, how we did like the local first part, how we did the sync engine. And for more information, you can check our website. You can check our GitHub repository. It's open source. We have the Apache license 2.0, one of the most permissive license. You can build and contribute on top of that. You can get updates in the our Twitter account, or you can contact directly me on Twitter. And if you have any question, feedback, or anything, it will be more than welcome. Thanks a lot.
Thanks, Hakan, for the wonderful presentation. And if you have like a short demo video in the Q&A section, maybe you can kind of show us Pull out in action. Well, I'm
Yeah,
sure
yeah,
people would
yeah.
want to
I will
appreciate
do
that.
that. Sure.
All right.
Okay.
If you don't mind, to stop sharing, and then I'll
Yeah.
take over. Um, Next up, we have Mikhail, and I know I killed his name. I'm sorry. I even had some training before it started. This is just me being Ethiopian. Funny story, I'm actually diving in from Ethiopia right now. He's been in this space for a lot longer. Maybe Aaron might have you beat, actually. Aaron was doing a local first talk before the word even existed. But I got zero data was what led me to the remote storage and the unhosted. And there used to be like an app inventory page. Couldn't find it. I wanted to share it with people. But thanks. Very happy that you agreed to give us a talk, and I can't wait for what you have in store for us. So over to you.
Uh, I'll try my best to live up to that. So, yeah, unhosted web apps is something that I started working on in 2009, I think, so like 15 years ago, because it is partially about local first, but it's also very much about data portability. So, local first is one part of it. So, the idea of unhosted web apps is to liberate people from the capitalism of the platform monopolies of Web 2.0 and to make it all open source and open network and the way the internet was intended to be. And with this in mind, we thought, well, we have to write some software that makes the web better, and we tried. um, so unhosted web apps with remote storage. This is about apps that run in your browser, and this was a novel thing at the time. Gmail was starting to use more and more Ajax, and there was the Chromebook that uses HTML5 as an apps framework. And even yeah, people native apps didn't really exist yet. People said, well, if you want to build an app on for the iPhone, then you can use a web app. Um, so there was a lot of hype about HTML5 and JavaScript in the browser. And then the idea that we had was, well, what if these apps don't store your data? And so that your data doesn't go into the hosted and servers of all these server lords and investors, but it stays with you and it's sort of unhosted. And we found this village, which is actually near Prague. It's called Unhoshed, but it's written sort of similar to Anno. So we just went there with our self-printed, screen-printed unhosted.org T-shirts. You can see I was a lot younger there.
That's so
We
cool.
had a lot. Yeah, we offered a Club Mate bottle to the mayor of this village. We're just generally having a lot of fun. And then we got funded by the NLNet Foundation. So I can shout out that to anybody who doing any sort of open source work, especially for local first, just ask for a grant from an LNet foundation. And if you're doing cool stuff, then they can give you 50,000 euros so that you can work on your stuff for a year. And they're a very nice funding organization. It's not a lot of work to get funded by them. So in unhosted web apps and remote storage, we use tree-based sync. So we synchronize the data between the server where the data is and the app that runs in the browser. And it was pretty primitive, but it had some things that worked. So one of the things that we thought, well, you want to download only a subtree of the data, and it was pretty simple. We just used a file path and we say I want to download that folder and that folder and that folder, and that's something you can do in the remote storage JS API. You say which folder and it will tell you when it's done. And then to stay up to date with the server, you obviously want to be subscribed some way to the changes that happen in those folders. Um, but we, at the time, WebSockets didn't exist yet, I think, or they were just very new. And so we just said, well, we can do long polling to the server, but if like a file is added to a folder, then we should change the e tag of that folder so that you can do an if non-match, and also change the e tag of each parent folder. So actually, you only have to long poll an if non-match of the root folder, and then if you see the root folder change the e tag, then it'll that request will go through and will tell you which of the subfolders has changed, and you can drill down to quickly find any change uh, that happened, and the sync library will take care of that for you. So if you use remote storage.js in your app, it will use this mechanism to stay up to date. And there then we called it remote storage as a pun on local storage, and we made the API as simple as possible and as similar to local storage as possible, which is slightly weird because local storage has a synchronous API, but that's what we set out to do. So that's actually how we got to doing. We have a copy of the full data in the browser, and you're updating that. You're making updates locally. Um, at the time, we didn't call it local first. We called it asynchronous synchronization because we like word jokes. And so there is synchronization between the storage in the browser and the storage on the server, but this doesn't happen immediately. This happens asynchronously. So we said, yeah, you have a local store and you have async sync with the server. And then sometimes a change will come in from the server, like in this case where a photo was added. Um, and you can subscribe to these events. And you can disagree with it because you have a local copy. So we call these keep or revert events. So the server will say, where this is this new file, do you want to keep it or you want to revert it? And if you want to revert it, then you just make the opposite change. So here's a little example where the client one in the browser storage has, if you look at the events list on the bottom left, it's you locally add foo, then you add bar, it's okay, okay, and oh, there's an incoming change. Somebody added baz. Okay, well, then we have three things. Oh, somebody removed bar. Okay, I just added that. Well, I don't know. And then you can decide, okay, well, let's leave it removed, or you can say, no, I do want to add it, so you add it back. And then if you look at the middle list on the wire, what actually happens is that the browser will send everything that's added to the server. And add foo has success, but add bar has a failure. And to the JavaScript, this failure, because it's asynchronous synchronization, there's nothing happening in the app at that point. It will come in as an event as if somebody else changed it. You are able to distinguish it from actually somebody else actively removing it so that that intent is preserved. So it will be marked as a conflict event saying, hey, there's now a removal and it's because of conflict. And if you look at the bottom right, there's this transcript of what the server sees, and the server is always right. So there's actually no CRDT in this. It's just the server is always right, but we use if non-match headers to make sure that um, you don't overwrite things that other clients do. And then yeah, if you were at the wrong e tag, then your if non-match header will fail. Then you can just fetch and try again. Pretty much how Git does it. Yeah, if you try to push, it fails. You pull, and then you rebase, and then you push again. Um, so at the time we were living in Berlin, and we were talking to the CouchDB and the Hoodie people a lot. We were actually in the same co-working space, and they were doing really cool stuff. And they were calling it offline first. So because we were doing this asynchronous synchronization, we were in tune with that, and we had a lot of conversations like, what should this look like, and what should the user experience be? How do you communicate to the user like, yeah, your change has happened locally, but it hasn't been synced yet. And we were just brainstorming user patterns there. And some people actually went to the offline camp for 4 days. They went coding in a place in the woods in Oregon or something with no Wi-Fi, just to find out how that works and to experience it. So yeah, that was fun to be a part of. Um, and but the main thing that we were working on was not this sync. This was sort of a side issue for us. It was interesting, and it's we wanted we felt it was important, and it was also connected us with the whole CouchDB thinking. But what we were very um, uh, much felt it was important was that the user can bring their own storage. Because if the app is in the browser, there's no server-side processing. You might as well let the user choose to bring their own storage. So the app will say, "Oh yeah, connect your storage," and it could be a remote storage protocol server, or maybe they bring their Dropbox server. And this was new, and this I think it was 2011, 2012. Dropbox actually added course headers to their API so that web apps could access their API from the browser, and Google Drive did the same. So that was exciting, and suddenly our unhosted web apps could access these APIs. Course header were a new thing. Anyway, um, and recently, actually, a couple of months ago, um, we added the Solid protocol as a storage backend to remote storage JS. That was done by my colleague Yashar. He's a very good software engineer. He was also funded by an LNet, and he built this integration. So now you can have a solid pod, which is another personal data store supported by the project from Sir Tim Berners-Lee. And you can have a remote storage JS based app, and this app will have um, the ability to store data there. So all these personal data stores are very much not application backends. So I think when all of you think of local first, you're thinking about the client and the client at your server. But in the unhosted project, we've always been thinking about the client and the user's server. So we call this no backend, and we came up with an emoji how to type that in ASCII. And there was one conference track once about no backend, and then sort of fuzzed out again. So connecting your storage, sorry, feels like logging in. It says like, yeah, connect your storage, and you can start using the app. It also feels a bit like OAuth, and that's actually a better comparison because you are giving this app access to some scopes on your storage, and that was a hard part to get right. And what we did was to do it in a very straightforward way. We said, well, yeah, the root folders of your storage are the data scopes. And when you say, like, the app Lightwrite wants to have access to your folder documents because it's a text editing app, um, then your storage, in my case, I'm using 5 app storage, which is a remote storage server. You could allow this app access to your documents folder, and it will use the OAuth implicit grant flow to get access from the browser. at the time Pixie didn't exist. We added Pixie later, so now it's actually secured. It wasn't before. Um, and this is nice because then you can say, "Oh, I'm going to pay for my own storage, and it will feel like I have control over my data." And these applications are. It's just like it was when it's just with just desktop applications where there was no cloud, where as if it's your own hard drive. But that still means that on your storage, there's all types of eligible data which you can't read. It's just like a zip file takeout. So all this talk of data portability, uh, there's websites are required to allow you to take out your data, but when you do, you get a big zip file with JSON files that you don't have any use for. So for true data portability, you need to look at data schemas. So we have conventions documentation, where we write down the conventions of how different apps write down address books on a storage. We have reusable code, like this one is a bit of code for building flashcard apps. And because it's all open source, it's all JavaScript, this felt like a good way to do it. Like, let's all use the same npm modules. Um, and a third way to do it was somewhere in between documentation code is with declarative code modules. So this is an example of a documentation project that uses shacks and shackle shapes, sort of like JSON schema, but for RDF, and to write down what the data should look like. Um, and if we can get the schemas right and we can get the scopes right, then we can say, well, these apps get access to the schemas, and then we would have portability. But yeah, spoiler alert, in 15 years, we built a lot of demo apps and they work and we can demo like, hey, yeah, this app has access to my bookmarks and now this other app also has access to my bookmarks. But we haven't got to the point where there are just a lot of apps that are compatible with each other. Um, some of it's organizational, I think. Some of it's just how software engineers work, and I'm guilty myself as well. It's just you start from scratch. The first thing you do when you write an app is you come up with a data schema, whereas you should just start from the existing schema. But then there's a chicken and egg problem. Like if there's no easy to use libraries of data schemas, um, then you have to invent your own, etc. So this is still something that we need to fix in the future. So I've been thinking a lot about how we can do better. I've been trying and failing, like we think documenting everything and keeping running into projects that do things from scratch. You say, well, at least document this other data format that you used. And I've never really succeeded in getting two projects to use the same data format. Um, but I think the Cambria project is very promising, and this is a these lenses, the Cambria lenses, are a declarative way to build data schema translations, which is sort of in between documentation and reusable code. So maybe that's in the sweet spot. Uh, Cambria project was temporary, and I think it'd be cool to keep working on it. Um, so maybe I'll try to do that in the future. But anyway, this was a short um, overview of what happened in the unhosted projects 15 years ago and more recently in the Solid project. Thank you.
It's an awesome talk. And like this idea of like merging different data stores is something that's really near and dear to my heart too. And like Cambria, I got really excited, and it's only TypeScript based too, which is a little bit tough to kind of use from different kind of areas. But looking forward to the Q&A chat with you. All right, next up we have Aaron Bogman, and he needs no introduction. He's a repeat speaker, and if you haven't heard about the Zero launch, uh, crawl out of that cave. They're all over the space. Like sync but good, and like email but good, data but good is now my new way of trying to talk about things when it comes to local first. He's been around for a while. He's one of the first speakers in this community, and I'm really excited for your talk, Aaron. I think you're muted right now. All
All
right.
right, how about now? Can you hear me?
Yep. Wonderful. Yep.
Epic. Okay. All right. Thanks for the introduction. Okay, so my name's Aaron. Can you see my screen right now?
Coming in great.
John's?
Yep.
Great. Okay. My name's Aaron. I'm the CEO of a company called Rossi Corp. This is our website. And we make sync engines. Um, a little while ago, I put this like pinned tweet on our Twitter account. Like about a year late after the joke of doing this. Anyways, so we currently make a few sync engines. We make Replicache, which we started in 2019, and is one of the most popular sync engines on the web right now. Um, but we got a lot of feedback on things people were struggling with Replicache over the years, and we felt like we needed a fresh start. So we started Reflect like 2 years ago, but we learned pretty quickly that it wasn't quite right. It wasn't quite the right shape, and so we deprecated that and we started Zero last year. Um, and in December, we launched Zero in alpha. It's got really good, really interesting feedback, and people have started using it, and that's what I'm here to talk to you about today. Um, so I keep using this word sync engine. We're at Local First Web Meetup. What do I mean when I say sync engine? I guess let me make this full screen, sorry. Um, what do I mean when I say sync engine? So there's a lot of terms floating around in this space. We just heard offline first. Um, I worked on things called offline first in the past. We use the term local first a lot. And I think the terms, as a community, we're still trying to figure out what these terms mean. Um, the past like months, I have settled into an idea of this new terminology that I really like. So I'm going to be trying to use it going forward. And I think about it in terms of these concentric circles. Um, I use the term local first to mean the original, like pure 7 ideals local first from the Ink and Switch paper that includes data portability, service independence. The service can go away, can go out of business, and you can move your app to a different service provider. And this is a really interesting idea, a really powerful idea. Is very, very like ambitious. Requires like dramatically different architecture than most applications are built with today. And there's very few applications yet that meet these ideals. The one that I can think of that I always like point people to think of what this means is like mail.app. You can take your mail client, you can point it at a totally different mail server that's run by a different company, and it works because there's a standardized protocol for what mail is. But there's very few like data formats and applications that exist like this so far. Then like one step out, you have offline first. And this is like using the same ideas of like sync that make local first work, but using it with like a classic centralized server that like almost all applications today use. So you get like a lot of the benefits of local first, but you don't get the data portability and the independence. You're using an application from a particular company. And the primary benefit of doing this is you get an app that works really seamlessly offline. Um, but there's an even broader class of application beyond this. And I think this is really like where the meat of the like need for these tools is. And I'm going to call these synced applications. And this is things like Notion, in my opinion, linear, superhuman, and really what people are using sync engines for in these applications is for the UI benefit. You get, when you build an application with a sync engine, you get instantaneous user interactions where every single thing you tap happens literally instantly in the next frame. You get full stack reactivity where a user changes something and every other user sees the change automatically. And you get a dramatically better developer experience where you abstract away network communication so that you don't have to the developer doesn't have to think about fetching, they don't have to think about handling errors, they don't have to think about asynchrony, they don't have to think about like loading states. They just read and write data locally. Um, and I think these are like the key benefits that really people are excited about with these tools. And I think there's going to be increasingly applications that are focused on these benefits. Um, and I think those applications should have a name. So I'm choosing the name synced applications for them. Um, all right. So but this idea of sync isn't new. It has been around for a long, long time. We just heard about people working on this like a decade ago. I myself started working on it on and off in like 2008. But we can go way further back. Actually, like one of the original like really popular GUI applications, Lotus Notes, which like predates Excel, um, was built on an architecture that we would today describe as a sync engine. Um, and then Outlook is like a classic offline first app built in '97. And over the years, we have seen like a steady trickle of these apps that have amazing user experience that are built on sync engines, Quora, Meteor, Slack, Notion, and now recently Superhuman Linear. But for some reason, it hasn't broken through. Like still, the vast majority of applications are built using classic HTTP APIs, stateless APIs, three-tier architecture, and they are not taking advantage of sync. Um, and as a person who cares a lot about really high quality UI, and who believes that sync engines deliver these benefits, and who's working on a company that builds sync engines, it's very interesting to me like why this hasn't happened. Why hasn't this broken through to the mainstream? And a few years ago, like I think at Rossi Corp, we had pretty much figured out like why this is happening. And it really like boils down to like a few core problems with sync that are challenging for most applications. There are permissions, large data, and quick startup. By permissions, I mean that like, the vast majority of applications that are online today are collaborative in some sense. They have multiple users, they have a bunch of data, and not all users can see all data. Think about Notion, think about GitHub, think about Google Docs. Like all applications, virtually all applications are this way. You have permissions to certain data, and how you have permissions to get access to that data can be quite complex. Like, this pitch presentation that I'm looking at, I shared it with my coworker Alex. I shared it with like a guy that isn't in my company, but who I wanted early feedback from. I can share links on the web. So how like what determines whether I have access to a particular piece of data is complicated. Um, and existing sync engines give you ways to partially sync a subset of data, but those existing mechanisms are not rich enough to really easily describe these kind of permissions that the typical applications want to do. Um, a similar problem with large data, like, and this is a little bit of a counterintuitive one, because when we think about, applications like, common applications that we use every day, it's easy to think, well, like, um, I could download all of the data that that application needs to my device, and I would have it local. Um, but there's always, for any given application, there's often a few users. There's like 70% of the users maybe can like download all of their data onto the device comfortably. But there's always like a few users who really love the application and use it a lot and use it for like their whole life, and quickly like accumulate more and more data. And the problem with sync engines as they exist today is that they sort of predicated on this idea of pre-downloading all the data onto the device, or like, they really want to operate in that mode where they're really downloading the majority of the data onto the device. And as the user as your app becomes more like used by users, as they like it more and they use it more, the app gets worse because it's downloading more and more data at startup. It's slowing down startup, it's slowing down the initial startup when the user has no data, and it's also slowing down like each subsequent startup because sync has to check all of that data that's been downloaded. um and you eventually get to the point where you can't download all this data onto the device at all, and so it falls apart. And that's kind of like the opposite thing that an application developer would want, right? They want, as their um as their application becomes more popular and more used, that it should scale nicely. Um, and another version of this problem is like quick startup. Um, a lot of web applications really care about startup speed because people may leave the app open all day, but they may also like click a link. There's often like public views. where people who are not regular users of the application can go and see a view of the data in the application. And for those users, um, that view should start up really quickly. Um, and there's also users who, some users leave their app running in a tab all day, but there's also lots of users who like close tabs like rigorously, and they're constantly clicking on links to go into the app, and they need the app to start up really really quickly. Um, so when you look at these problems, it's kind of interesting. They all kind of like they kind of all like distill down to the same issue. We think about like how to describe the data that a user should be allowed to sync. Most applications today, it's a query, right? It's or a set of queries that describe the data that should be sync or sorry, that a user should be able to access. And if we think about like how to describe the data that we want to sync onto the, like you have a lot of data and we only want to sync a subset of it, a way to describe that data that would be natural would be a query. And ideally, the application could take a guess at a subset of data that the app thinks the user is going to need and express that as a query and sync it. And if the user navigates elsewhere in the app, then we can again use more queries to describe the data that the user wants to access in the new area of the app. And with Quick Startup, if we had these queries, um, we could use a query to describe the data that the user wants for a particular page when they navigate to that and sync that first. And then add more once that data is synced, add more queries to download more data to get the data that we expect that the user will most likely need for the rest of the app. So like it has been clear to us at Rossi Corp for a while now, for I don't know, a couple of years, that really what's needed to make sync go mainstream and to give more applications this really high quality UX is query driven sync, where instead of describing the data to sync in some kind of, as a bucket of data that you download or as a bucket with like basic filters, you use full rich queries to describe the data that you want to sync. So like the sort of napkin sketch of the dream that we've had for a long time is like there could be some client-side API where you express a rich query with joins, with filters, with ordering, with limits right in the UI. And that query, yes, it runs against local data, but it also controls the data that should be synced to the client. And only the data that's like active, that only the data that like the that is represented by a union of these queries is what's getting synced at any moment in time. And if you had this basic tool, then you could solve all of these problems in a really like natural, composable way. And you could build applications like Notion, Linear, and Superhuman, and whatever else you want out of this basic primitive. Um, so we knew about this for a while, but we didn't build it because there's some really significant challenges with trying to do this. First of all, you want to, if you're going to build your whole application out of these queries that sync, each session that's like active, each user that's running the app is going to have like many of these queries, maybe dozens of these queries running. And if you have like thousands and thousands of users running the app at one time, then you're going to have tens of thousands or like hundreds of thousands of these queries active. And you have this question at the core of it, of like, when do we rerun a query? Like if we have 10,000 open queries on a server at one moment, and one row of the database changes, which of those queries do we run again to figure out which rows change to sync to the client? And this is a very like gnarly challenge. Think about even like a really simple query like select star from task where priority greater than 3, limit 1,000. If one task row changes in the database, how do we know to invalidate this query? How do we know that this query should run again? Because of we could look at the query and say like, okay, there's a priority column in there. It's filtering on priority. So maybe if the priority row column of the row has changed, we should rerun this query. But then think about the limit in there. Like that makes it pretty subtle because we have to know if the row was part of the window that ended up getting synced to the client. So we have to know if it fell inside that limit. And you might think, well, we can keep like the high watermark of the, we can keep the last row that was synced in this window. But even that doesn't work because like if a row is deleted, it will like end up leaving a spot empty in the window, and now we have to go find the next row that should be synced into the window, and the reverse can happen too. If a new row is added that goes into the window, then we have to send a delete to the client for the row that got removed. And this is like a really simple example, but this spirals into like crazy complexity really, really fast. Like take another really basic query like select star from task, inner join on user. So we're going to get the tasks with the users that own them. And we're only gonna get the tasks that are for user 42. So if we have this query open and a task changes, a task row changes, should that row be synced to this client? Well, we have to know, if it we have to look at its owner. And if its owner like changed and it's owner 42, then we sync it. And the opposite like is also complicated. Like if a user changes, um, it's kind of silly to think about a user changing to like be another user's ID. But in the general case, like if a user changes, we have to think about like, okay, has this user changed such that any of these task queries are now invalidated and it should be rerun. And these are really simple queries, but like, if you get into the kinds of rich queries that like an application would want, this gets really, really complicated. And then we have another challenge, which is if we're thinking about running queries, shoot, I forgot like earlier. Anyways. One of the things that we would want to achieve, like with this API, with this query-based API, is we want when you run a query, it should you could build an application out of these queries, and when you run the query, it syncs, and it updates reactively. And then when you execute a new query, the new query should reuse any existing data that's already synced on the device. And that's what makes it different from like existing systems that like use that use reactive queries. Like today we have systems like Supabase and Firebase where you can execute a query and it does run reactively. But every time you invoke a new query, it's slow. It has to go all the way to the server and start synchronizing again. So to make like a query-based sync system where you can build things like Linear and Notion and where everything in the app responds quickly, you need each new query to reuse the data from previous queries. If we're going to do that, we need to run queries on both the client and the server. So whatever we build to solve problem number one, we have to be able to run it on both the client and the server. So if you've done any work with databases, you might recognize this problem. Problem number one, it's called the incremental view maintenance problem. It's like a famous problem in computer science. It's been known for a really long time that incrementally like maintaining the result of a database query is a very difficult problem. And it's been something that people have worked on like on and off for decades, but recently there's been two really interesting advances, like relatively recently. There was this paper, DBSP, that became the product Feldera. And there was another paper, partial state and data flow based materialized views, that became the product Noria. And both of these products are really intended to be used on the server. The idea is you have some huge database that has lots and lots of data in it, and you have a query that you like frequently run for like reporting or something like that, and you want to keep this query up to date. These are alternate ways to do that are efficient. So they're not really intended to be used in UI or sync systems. And we kept waiting at Rossi Corp for like somebody to apply IVM to the UI problem, and hoping that somebody would so that we could use it in a sync engine, but nobody did. And so last year, we decided that we were going to take a swing at it ourselves. And we used the DBSP paper as inspiration, but our solution ended up kind of similar to the partial state design. But it also has some of its own unique aspects. And this like IVM based query system is like the core of Zero, and it is what makes query driven sync work. And we call it ZQL for zero query language. And I am not going to be able to explain SQL in like a 30-minute talk, but I can give you an intuition of how it works. And it's a really like beautiful, I think a really beautiful system, and I hope it piques your interest. Um, so like a normal database, when you have a query, like any kind of SQL query, what it does is it sort of breaks it builds an abstract, an AST of the query. It breaks that query down into like a kind of pipeline, and the pipeline has operators in it, like filters, which I've represented as circle, joins, which I've represented as a hexagon, um, limits or takes, which I've represented as a whatever, a round rec. Um, and data sort of flows through this pipeline, and that's how you compute the query. And these operators are like composable. You can build pipelines with different shapes. You take a query and you break it down into one of these. You run the data through, and the query comes out. But the way normal databases work is that the input on one side of the pipeline is the whole database at a particular moment in time with its indexes. And so you query over this you iterate over the database, you filter it, you join it, and out pops a snapshot of the database at the end. And the way IVM works is like a similar like idea, but instead of taking the whole snapshot of the data, we instead take deltas of the data as input. So we have one of these pipelines, and the input is a change to a single row. In this case, a single issue row, being added, deleted, or edited. And this issue row flows into the pipeline. It's ordered in this case because our query is ordered. We filter it on whether it matches the criteria, and we like maybe discard the change if it doesn't match. Um, it flows into a join, and at this join operator, if it's being added, we go and get the comments that apply to it, and then we send it on down. We figure out if it matches the limit, and if it does, we send it out. And what pops out at the end of the query is a change to the query result, um, not a change to the database. And similarly, like we can do the same sort of thing. If a comment changes, it flows into this, it goes into the join. We see if it matches the join criteria. If it does, we go and get the corresponding issues, and it flows down the pipeline. And sort of what comes out of this system is these really precise updates to queries. So like for this query, we have issue where owner is Aaron, order by created descending, limit 100, related comment. And we send changes to the database in one side of the pipeline, and the output is changes to the rows of the result of the query. So like with this basic primitive, we can build a sync engine. And it looks kind of like this. You have your client-side application with the user's app code. You have the zero client, which is a library that you embed into your app, and it has the SQL query processor inside of it. The app subscribes to queries, and we have client-side storage that the SQL query runs against continuously. And when this client-side storage changes, for example, because the user made a change, that change flows into the front of the pipeline. It goes through the pipeline and out pops a change to the query result, and the app renders. And you get these like really nice, like super precise like changes to the query results, so we can like update only the part of the UI that matters. But like more importantly, from our point of view, we can run the same SQL on the server. So when the app makes that query, we also send the query to the server side. On the server side, we have this component called zero cache that keeps a replica of the data in the authority. Like we have any kind of like classic database here, like Postgres or MySQL in the future. We keep a replica of that data in zero cache. We run SQL continuously against that replica, and as data comes in as changes come in, like if a change is made in Postgres, we replicate that change into our replica. SQL runs on that, sees that row come in. Um, the change flows through our pipeline, and the result of the pipeline is a change, a change in the query result, and we send that row down to the client. It goes into the client storage. The client side SQL query runs again, and the UI updates. So we solve this problem too. By building our own query engine, we can run it on both the client and the server. and get this like really elegant system where the same queries are running continuously on both the client and the server. So this is a lot of work. And one could naturally ask if it's worth all the effort. And to answer that question, I think like the best thing is to see it in action. So when we started Zero, we knew that it was going to be an open source project, and we knew that as an open source project, we would need a bug tracker. But like we couldn't swallow the idea of using GitHub because it's so slow, and it's like sort of the antithesis of what we're trying to do. And we also couldn't use Linear because Linear doesn't support open source projects. It doesn't have public bugs and like granular permissions that you would need. Um, so it became sort of obvious that we were going to need to build our own bug tracker. And so along with building Zero, we also built a bug tracker. And we use this bug tracker we call ZBugs as our actual live bug tracker. So these are all the real bugs for Zero, the current active bugs. And we use this as like a kind of dog food to both show off Zero and also so that we're continuously using Zero and feeling like how it works. And it's completely synced, so everything is absolutely instant in this app. Our design goal with Zero is that 99% of queries respond in less than 1 millisecond. So as you move through this app, literally everything you do happens absolutely instantly. You can do complex filters. And like if I press next using the J key, I can even hold it down. And these queries are updating at like literally 60 frames per second. Of course, it's entirely reactive. So if I open this in two windows, oops. So I've got incognito window on the left, and my signed in window on the right. If I change something here, it goes away. If I change it back, it comes back. Everything's totally reactive. So like if so this query is like sorted by last modified descending. Let's say I change something in here, then the row should pop up to the top because it's been modified. So if I like, I don't know, change the assignee to me, it pops to the top. I'll undo that because I don't want to take responsibility for that one. And that just happens automatically because of the fact that the developer, when they created this view, expressed the query with an order by. And so there's nothing that you have to do to make this reactive. It just happens completely automatically. Also, because we have query-driven sync, the app starts up crazy fast. Like if I what is variables? Clear all the data, reload. It's like less than 1 second that it takes to load. If I go into a detail page and reload, it's like that's how fast it takes for a new user who's navigating to this link to start this app. But then when they go over here and do a filter, it's also instant because what happened was when we navigated into this bug, we loaded just the data. We used a query to sync just the data that's needed for this view. And once that was done, we added a query to sync the data that's necessary for like the first bit of this view and built out the data that was being synced incrementally so that like most likely as the user navigates through the app, everything that they hit will have already been synced. But if they're fast, then the view will still work. The sync just like will be a little bit slower because it's happening on demand. We also have like permissions in this app. You can log in. If I again go to a logged out window and like say I mark this bug. Hello. What the heck? My computer is like dying. Okay, that was weird. If I mark this bug like private, we have the concept of private bugs, and we're an open source project, so we need bugs that are internal only to the team. If I mark this bug private, it should go away from this view because this user is not logged in, right? He's logged out. Um, so I do that, it goes away. Oops, all right, sorry, I changed the wrong thing. Okay, I'll change the visibility. It goes away, it comes back. And this is actually like unsyncing the data from this device. It's not a client side thing. Um, Similarly, we have write permissions. So if I'm logged in, I can like, oh, I can't really demonstrate this because I don't have another user, but if you visit ZBugs and you go to one of these bugs, you'll be able to comment if you log in with GitHub, but you won't be able to change any of the properties, like status or assignee or anything like that, because you have to be a project member to do that. And this is all enabled because of ZQL. Um, so if we like go back to this question of is it worth it? You know, this is obviously like a huge project. The idea of building our own query engine. Um, Databases are like famously hard problems. And like a streaming novel database is even worse. But like some things in the world are hard. Some things in computer science are hard, and those things still need to happen. Like, um, we I feel like we have pushed the three-tier architecture of the web like as far as it can go. We've like optimized the crap out of it, and the only way to make the web faster is sync engines. We have to move the data to the client early. And like if you look at things like databases, React, these are complicated abstractions, but they contain the complexity like inside the abstraction so that the tiers above don't have to know about it and can be much simpler. And I think that like ZBugs demonstrates like how well this works because we were able to build this bug tracker that's like, a pretty good like subset of linear with like a few people as a side project while we were building a database um, in a few months. Um, so I think that, you know, I think this is where the web is going. I think this is where sync is going. We made this project open source because we could not possibly build this on our own. It's just way too big of a thing. Um, and we've already had contributions since we've launched for Svelte, Vue, Windows, Mongo, like GCP, more even like probably more than I'm not thinking of. So if you're interested in this kind of stuff and you want the web to move towards a synced model, um, we would love you to get involved. You can go to zero.rossicorp.dev to learn more. You can play with ZBugs. You can join our Discord. Uh, and if you just want to try Zero, um, it's in alpha. There's still a lot of missing features, some rough edges, but it works. We built a bug tracker with it. So give it a shot and find us in Discord. Let us know what you think. Thanks.
Awesome talk, Aaron. And I want to give Matt also a shout out for a new member of the Avengers team at Rosico. Aaron, could you show that like the old GitHub demo? I don't know if you where you like
The
just have it
old,
on the
the
main
old,
page, like the
what's the
Rosicore
old?
page. The Rosicore page has like GitHub but with
Oh,
local first data. I think that would just like I don't want to see the zero version of that coming in, so I don't ever have to open up GitHub again. Right.
I don't understand your question.
It wasn't a question. I was just saying for the people on the audience, like you saw how
Okay.
fast bug trackers were, and they started off sort of rewriting the GitHub issue tracker and everything in Replicache in the beginning. And this video was one of the most eye-opening videos for me.
Yeah,
I'm gonna want to share it with people. Maybe drop the link in the chat. Maybe that might be
yeah,
easier if you
we'll
don't
do.
want to pull it open.
Yeah. The funny thing is like, we've done this demo, the linear demo in the past. A lot of teams have done the linear demo, but like we actually needed a bug tracker. So like
This is
rather this
production.
time rather than build a demo, we were like, let's actually build a bug tracker and use it.
Yeah, yeah,
But yeah,
for
I'll
sure,
drop
for
this
sure.
link in the Discord, and
People
even
can
better,
check
just
it
try
out.
debugs and experience for yourself how fast it is.
Yeah, I checked it out when it was launched. For folks in San Francisco, uh, we have Raspberry coming up to make a quick announcement. Aaron, if you stop sharing, I'll let him take over the screen.
All right, I'll try. Oops.
Are you still with us?
Yeah. Hey guys, can you hear me?
Yep. Video and screen share are not showing up though.
Okay, that's fine. I'm not gonna share anything. Hey guys, thanks. All the presentations were super cool. Thanks, Jans, for putting this together once again. You always invite the coolest speakers every single time. I don't know how you do it, but it's amazing. Just a quick little thing. Me and some people here in San Francisco are organizing a hackathon for local first and local AI. So if you're interested in like just coming together for an evening, it's like 1 day long on Saturday, February 22nd. If you want to just come, hack, hang out, we're gonna have snacks and food and stuff. I'll post a link in the chat. There we go. And then also be posting some updates on Twitter as well. So if you want to just know about any updates, you can also follow along. I'll share that link as well.
Awesome, awesome.
Yeah, but yeah, if you're in San Francisco on February 22nd, definitely come through, and you can just hit me up if you have any questions and stuff. Cool.
Yeah, cool stuff.
Thanks, y'all.
This is that point when we stop the recording and basically